So tonight we are especially excited to be able to offer you a video conference with NASA scientist Darlene Lim. So that's who you see up on the screen, and she is coming to us from California. Darlene, can you remind us what city in California?
I'm in Menlo Park, California, which is adjacent to Stanford University.
Okay, so that's where she is right now, and we're going to ask her a bit about what she does for NASA. She works at NASA, and we're going to ask her a bit about her job, and then we're going to go straight to some questions that we got from children around the province. Children just like you who were interested in science. So first question, Darlene. Can you tell us briefly about your job, what you do for NASA?
Sure. So I'm a research scientist, and my background is actually in something which most people don't think about when they think about NASA, and that's aquatic sciences. So essentially, I'm a limnologist, which is kind of funny because my last name is Lim. But what I do is I study freshwater systems. Now, the reason why that's of interest to somewhere like NASA is because two things. First of all, a lot of interesting things happen underwater. And my specialty is actually looking at really cold places underwater. So I started working in the Arctic and the Antarctic when I was in graduate school. And since then, I've moved on to other lakes, which are cold. They're not situated, up at Arctic latitudes, but just in your backyard, a place called Pavilion Lake, which is about 4.5 hours eastbound of Vancouver. It's a very interesting place. It's cold at the bottom. It's 4 degrees Celsius. But what we find inside this lake are microbes, so bacteria, that are doing really interesting things. They're building up rocks. And those rocks that we find in this lake are basically what we call analogs to rocks that we find in our early Earth's history, in our rock record. So by sort of examining modern environments, so present-day systems like the one that you have in your backyard, we can get an understanding for what early Earth might have been like. And so NASA's interested in those types of analogs. But the other cool thing about my job is that because I work in underwater environments, that's a really nice analog, once again, or comparison to having humans work in space. It's an environment where it's not safe for humans to be for too long. We have to wear equipment to actually allow ourselves to be in that environment for extended periods of time. And the other thing is that all of the different systems that we put in place to manage humans underwater or in space are very similar. You need to make sure that they've opened up their planner and they know that maybe they only have 15 minutes somewhere, and if they take 20 minutes, what are the consequences? So there are all these different types of things that we put in place. We try and understand how to track humans as they move and gather information from what they're saying and make sure that's all coordinated into one place. And all of that has relevance for when we eventually see humans go to the moon, go on to asteroids, and eventually Mars. So my job's awesome. I went to NASA because I was interested in the earth sciences and because I have a very deep-seated passion for human exploration, and I figured NASA was a pretty good place to go to indulge both of those loves.
That's great. So where did you start your university career? And this is actually one of the questions that the people were asking us. Ephraim from Burnaby was asking, what was your university career like?
So I actually went to Queen's University for my undergrad, and I took biology. And then from there, I was going to start graduate school right away, but I got a job offer to work in advertising, of all things. And
advertising.
And sorry, one of my little ones just walked in. And and so
I'm thirsty.
Hold on one second. Sweetie, can
We'll
you
send
get
you some
Amelia?
rain. Okay. Do you want to say hi to BC?
So sorry, one second. Amelia,
problem.
Daniel's going to get you some water, okay? Thank you, honey. So
Let's give a big hand for all those working parents out there, like Darlene Lim.
So
Thank you.
Anyway, thanks for your patience. Tonight I'm juggling. My husband's on travels, and so we're juggling the
Right.
three of us.
Thank you.
But
for coming.
in any case, so I started at Queen's, and I did a biology degree, and then I actually got a job in advertising. And my graduate supervisor to be, when I was finishing my undergrad, said to me, go do that for a couple years and find out what you think about it. And then if you still miss science, then come back to science. And so I went away, I did advertising for 2 years in Toronto, And I found that every, spare moment that I had, I was reading some sort of scientific journal. I was, always interested in that. I was always talking with these people I was supposed to work with at Queen's and asking them what they were doing. So it was pretty obvious what my passion was and where my heart lay. And it was a great job in Toronto, but then I left it and went back to grad school in Toronto. I did my master's and my PhD there in the Department of Geology. And my field was, once again, limnology and paleolimnology. And paleo means history, so I looked at not only present-day lakes, but also the history of lakes. And I focused in the Arctic.
That's great. So let's go to another question that we got from Bailey from the Ridge. And she says she's thinking about NASA's overall job, and she's asking us, why do we go to the moon?
So that's a great question. Now, we should talk about why do we go to the moon as a question unto itself. So we haven't been to the moon since 1972. So that was when I was born. That's a long time ago. And we would like to go back to the moon. And that's one of the potential stops that NASA and other countries would like to go to in the future. And that's because it's close by. It doesn't take a long time to get there. It only takes about 3 days to get there. Once you get there, you're not that far away from Earth. The other cool thing about the moon is that when you have humans on the surface of the moon, there isn't a long lag in terms of the communications between someone on the Earth talking to somebody on the moon. It's only about 1.2 to 1.7 seconds one way. And so that's, it's kind of like talking to somebody overseas when there's a little bit of an echo, there's a bit of a lag. It's irritating, but it's not that big a deal. But when you start to get people beyond the moon onto asteroids and onto Mars, that's when the time lag moves from 1.5 seconds to 50 seconds one way to 30 minutes, 40 minutes one way. And so it's much more dangerous because if something happens, that's a long time to wait for a response. And so it changes the way that humans have to operate when they're on those different planets. So we want to go to the moon as sort of a potential first stop, or one of our first stops, because it's close, because of all those kind of operational, perks that you get from not going too far away, but from trying to extend our human presence from just low Earth orbit, which is where we have been and where we are with the International Space Station, to somewhere else where humans will be more challenged and have to really learn to live away from home, but not too far away from home. It's like for me, when I went to Queen's University, it was far enough away, but not too far away. I could still come back, versus going, let's say, to the other side of the world to go to school, which is much more difficult.
Okay, so some more questions for you.
Yep.
A little girl here at Burnaby Library, which is where we are tonight, she asked me at the reference desks, if whales can breathe underwater, I wonder what would happen in space. And
if whales can breathe underwater, so
I think
that's interesting.
Yeah.
So whales actually are interesting because they look like fish, they seem like fish, but they're actually not. They're mammals. So just like us, we have to hold our breath if we want to stay underwater, or we have to put on scuba gear. And you can talk to Donnie about all the wonderful things about diving and using scuba.
Yeah.
But otherwise, we have to hold our breath. It's the same thing with whales. They have to hold their breath when they dive down, and then when they come up to the surface, you see them blow out their spout, and they actually will intake more air and fill up their lungs and then dive down again. So they're just like us, which is really fantastic because we're not certainly as adept at swimming underwater as they are, but we're actually connected because we're both mammals. And so I wonder if the connection, or perhaps I'm not sure exactly where she was going with that, but certainly, when you think about whales being underwater and the fact that being underwater is where we actually go to learn about being in space. I mean, there's a lot that, is a crossover there. So I think it would cost taxpayers a lot of money to try and put a whale in space, but, never know.
Yeah. I think she knew that you studied lakes, so she was thinking about Burnaby Lake here in Burnaby, and she was thinking about whales and how space might be similar to a lake. So,
gotcha. Yeah, that's a great question.
And I have another question from a young scientist, Nora, age 8. She likes going and collecting samples when they go traveling. Where does NASA collect samples from? Like which planets?
So we've actually never collected a sample from a planet. We have collected samples from our moon, however. but there's never been a sample return mission from any other planet. We have collected samples as well from the tail of comets, but never from the surface of a planet. So something that has been in the works for some time is a discussion about a sample return mission to Mars. It's very expensive to do. There's a lot of technical aspects associated with that, but that is what's in the pathway of what's called the Mars Exploration Roadmap. So there's actually a long-term strategic plan or a long-term plan that NASA puts in place in coordination with other countries like Canada and like the European Union. And they talk about, essentially, we talk about where we want to go, not only next year, but 20, 30, 50 years from now, when we would like to see humans set foot on Mars. And then they sort of use that as an end goal and work back from there. And one of the things that folks are interested in doing is actually grabbing samples either from the surface of Mars or from the subsurface of Mars and returning that back to the Earth so that scientists here on Earth can take their time studying it. Because right now, the only way that we have access to Mars is through robots, and that's the same for all other planets in our solar system. The only way we can get to them is with robots. We haven't put a human anywhere beyond the moon. And as a consequence of that, the only place that we have samples returned to us from by humans is the moon.
Mm-hmm. Okay, I think we have time for one or maybe two more questions. Ben from Vancouver is also interested in water, and he says how water and how it behaves in space. He says, bubbles in a carbonated liquid, how do they appear in space? Do they float up, or do they float kind of away from the center?
That is a great question, and my answer is I really don't know. And so I think Chris Hadfield would be better suited to answer that question because he did all sorts of different experiments. And it may be that somebody's tackled that on the International Space Station, but unfortunately it was not me. But it sounds like an experiment waiting to happen.
Okay, maybe Ben in the future from Vancouver will become a scientist like you and be able to answer that. Oh, so you did mention about how communication, there's a lag when we're communicating with other planets. So Alex from Vancouver says they wanted to know if faster than light communication is even possible. Now,
not right now.
Not right now. Okay.
No.
So faster than light sounds faster than that 30 minutes you were talking about, I think.
Well, you're right. So we're basically constrained to the speed of light in terms of any sort of communication. And so when we look at the moon, as I mentioned, it's like a 1.5 second kind of lag. It's not a big deal. But as you get further on to, let's say, the closest asteroid, so what's called a near-Earth asteroid, these are asteroids which aren't within the asteroid belt between Mars and Jupiter, but rather asteroids that are closer into the Earth, which we can reach with humans within a reasonable time frame. So the closest one in is still a 50-second one-way delay. So it's 50 seconds one way, sending a message from Earth to the asteroid and the humans there, and then another 50 seconds coming back. And then when you get to Mars, that can be as long as 40, 45 minutes one way. So what we've been doing at Pavilion Lake, actually, which has been a joy, is actually doing our science, but then within that science framework, we've been doing tests that help us to sort of mimic what it would be like if humans were trying to do science on an asteroid. So we've had humans underwater in submersibles, and we've had other scientists sitting further away talking to them with a 50-second one-way delay, and it completely changes the cadence, the pace of the operations, and it actually can really mess things up if you're not careful.
So, Darlene, we're almost at the end of our time, and I don't want to push bedtime too much further. First, my last two questions are, what are you going to read the kids for bedtime stories? What's their favorite right now?
Actually, because you asked me that earlier, I brought a bunch that we're basically obsessing about right now. But this is one of them. It's Manfish. It's actually a story about Jacques Cousteau, and it's really lovely the way everything is drawn in it. So that's one of them. And my daughter loves Tangled. So we are the land of princess here too.
Tangled. Does anybody out there know Tangle?
It's the
there's
Disney.
There's two girls with their hands up. Yeah, cool.
Yeah, she's an awesome heroine. We've gone through this, which of course, because I work for NASA, you can't get away from stuff like this. But I don't know if any of you have read this book. It's called The Astronaut Handbook. It's super awesome. And actually, one of the characters is probably based on one of the people that we work with at the lake. And it's probably this little cartoony guy right here who's supposed to be a deep sea diver.
Oh,
And
wow.
anyways, it's a really nice cartoon book about all the stuff, the training that the astronauts do to ready themselves. And then the last two that I'll show you is we love. You guys are probably familiar with this, Graham Bass. He's an Australian writer.
Yes, we love Graham Bass.
Yeah, we love him. He's awesome. And for some reason, my two kids get me to read this one again and again. It's called Ellison the Elephant. And it's actually a cute story because Ellison is a really different elephant, and he can't trumpet his trunk like the other ones can, but he can toot and he plays jazz. And so he's really cool, and he's got to find his voice. So we like him.
Oh, that's so great. Darlene, I'm running right back into my buying all of those books if we don't have them, and extra copies if we do have them. So everyone, those books, just give us a few weeks. If we don't have them, they'll be on our shelves. Please check them out from the Burnaby Library. And please let's give a great big Burnaby handshake to Darlene Lim.
Thank you. Thanks for your time.
Thank you so much.
Thanks.
Your good friend Donnie is here. I don't know if he's close enough to the mic to say hi. I know that you guys might be getting together in September. Hopefully there'll be lots of Pavilion Lake stuff happening soon. And I don't know, Donnie's going to talk to you about that in a few minutes. So thank you again, Darlene. Do you want to say hi to Donnie?
Thank you. Yes.
Hey, Darlene.
Hi, Donnie. Hi.
We will talk to you tomorrow morning, I'm sure.